various filters that are for larger contaminants, and then you have a smaller, tighter wind on the inside. So you can go 75-25, 75 on the outside, 25, 50-05, and 25-01. And that's nice because all it does is it increases your capacity levels. You can load up more stuff in those for longer periods of time, higher performance.
Our core water treatment system, that first housing, has a dual gradient sediment filter in it.
We have carbon impregnated paper cartridges, so that's just a pleated that has carbon on the outside surfaces of it, and again that ranges all the way up through carbon blocks and granular activated carbons as well. So when you grabbed it, Rusty, and you shook it, those cartridges are the ones where you're going to get the maraca with water to get through. Here's your GAC cartridges. The GACs are in like a linear flow cartridge, so the water comes up, goes down to the bottom and flows up through the bed and then out. That's just a bed of carbon. It's very similar to water flowing through a tank that's loaded with carbon. Then you have the radial flow, the RFC carbons as well. And to give you an idea of how effectively carbon is at removing chlorine, even those carbon impregnated, those pleated filters that just have carbon on the surface, those do a great job for chlorine reduction, especially in warm water. That's how quick chlorine can get reduced out of the water. It's just the amount of time that water flows through a sheet of paper. So very effective. Will Chlor Plus remove chlorine? Yes. In fact, Chlor Plus cartridges will remove chlorine exponentially better than a regular carbon block. In comparison, it's almost like they never run out of capacity for chlorine removal, the Chlor Plus cartridges. I want to say it's like somewhere between 5 and 10 times more chlorine reduction capability. So that's what the benefit of the catalyst that's been put on the surface. And again, I don't want to spend a ton of time here, but it goes through all the carbon blocks and talks about what some of the capabilities are. Here's the modified blocks that we make in Dover, American-made cartridges, high levels of dirt loading as well as carbon filtration. And then you also get the ability to go all the way down to that 0.5 micron filtration level. My favorite carbon cartridge, my favorite filter cartridge, the Flow Plus. I think this is an outstanding product to promote as a whole house filter. Specialties, there's our phosphate feeders, our ion exchange cartridges for water softening, mixed bed deionization cartridges, again for special applications to make pure water. And then this is, I don't know if any inquiries have come through for iron removal in this area. Is iron it is problematic? These cartridges have a particular catalytic media in them as well as the carbon. So what they are created to apply to, they do carbon filtration. It's a radial flow carbon essentially, but it also has a material in it that does iron reduction. So it'll precipitate and filter out iron as well at low levels. Okay, so you can see 1-2 parts per million of iron in the water. It's a really good polishing filter to take that out. And then again, it's cost effective. Rather than a whole iron removal system for a whole home, maybe you don't need to do that. Maybe it's just for the irrigation system or something. They don't want orange spraying on the side of the fences. You can just put in a cartridge like this, and it'll do enough to polish up that water for that kind of application. And it's easy to apply. Here's the Chlor Plus, oil absorption, and then our inlines and so forth. Okay? Everybody feel good about that stuff? Let's talk about RO. Okay, reverse osmosis. Let's talk about reverse osmosis. All right. What do we know about reverse osmosis? Here, we're going to kind of combine a couple of things here because we separated it up till now. We talked about particulate filtration as being a barrier and physically stopping things from passing through. And then we talked about chemical filtration, where we were using adsorption and we were kind of doing an exchange and kind of pulling things out of the water. RO is a means of being able to do really, really fine barrier filtration that gets down to the level of where you're removing and rejecting dissolved components. So you're doing chemical filtration, but you're doing it by means of a super, super tight barrier. And that barrier is called a membrane. So what we'll do is lay out a sheet of polymer, polysulfone, and subject that polysulfone to a solvent. And based on how that's done, time periods, amounts, and a specification, it will produce pores in that sheet of plastic. And those pore sizes are so small that it's semi-permeable. It's so small that it only lets water through. Only lets water through and passes and rejects everything else. Kind of cool, right? One of the things that's been, as the evolutionary process of the product that's worked out really great, is these materials, these membranes, have been, the production rates and the volumes have gotten so high that RO has become really, really cost effective too. I mean, as far as a means of water treatment, it's inexpensive and it's very capable and very dependable as a means of water treatment. There's a couple of pros and cons to anything, as there is with RO, and we'll cover those in a little bit, okay? But that's what a membrane looks like. And this is a spiral wound membrane. So what it actually is, it's like a poster. If you wrap up a poster to put in a tube, that membrane, that sheet, is wound around that core, that plastic tube that you see in the middle. And then based on which way the water goes and which way the flow of the water goes through that membrane is how the process happens. The way that, just for me, for ease of me, I'm pretty simple. I'm a pretty simple person. I like to try and, if you tell me about something, I like to try and translate that into things that I'm aware of or that I have a good feel for. And the way that I like to think of an RO membrane is, if I take mud and put it on the top of this table, and then take a sheet of paper towel, if I lay that paper towel on top of the mud, the water is going to migrate, it's going to go into the paper towel and start soaking through the paper towel and making its way to the edges. Just because of the nature of what that paper towel is, it kind of filters out the mud, right? The garbage, the granules, the sand and so forth. And it just picks up the water and then takes the water and spreads it out. That's kind of what's happening with an RO membrane. It's a semi-permeable membrane. It only lets the water in and it rejects everything else. Okay? So if I wind that paper towel and if I could flow mud through it, the water goes into the paper towel and that's what I'm collecting. That's kind of how I like to think about it. So semi-permeable membrane.
How many gallons per minute does this do?
RO membranes aren't rated, well, residential RO membranes aren't rated on gallons, you said gallons per minute, right, Rusty? They aren't rated on gallons per minute. They're rated on
per day.
Gallons per day.
Yeah.
So it's a very, very, because you're right, if I put that paper, it's not going to be making water where I'm going to turn on a faucet and all of a sudden suck the water out. It's going to be making water at a very, very, very low rate. 75 gallons per day, and that's rated, that's a 75. But if it's 50, some of the most common sizes that you're going to see now, 50, 75, and 100 gallon per day membranes for residential use, you're talking production rates that are into milliliters per minute. Very, very small, like drops of water.
Okay.
So
this would be used for like just drinking water then?
Primarily RO water is used in the residences. RO is used to produce drinking water. Really, really super high quality drinking water.
So this would be installed like directly before the
refrigerator.
Yeah.
Yes.
So instead of like a refrigerator filter, you would use this instead?
I would use it in addition to.
Okay, so this would go before your fridge out of the wall? Or?
It goes under your sink most of the time, and you have a faucet that comes up for a glass filler, then you can run the line to your fridge as well.
Okay.
Yeah.
And typically you'll have a storage tank under the sink as well.
Oh, so
that'll offset that slow production rate. So you'll always have water on demand.
So let's talk about how this works, because I actually have, just like what Phil said, and what Derek and everybody's been adding in, because I actually have an RO we're going to pull out and take a look at, so you can see what all that stuff looks like. Semi-permeable membranes are a necessity for life, because what it does is it allows water and electrolytes and the stuff that we depend on to be at balance on two sides, like on the cell walls and stuff, right? So you're allowing water to go through both sides to create balance so that things can operate at a level that provides for life. So semi-permeable membranes are natural. We're going to produce one that allows us to make water. Well, it's not, those semi-permeable membranes that are in our body, in plants and so forth, what they're using is a process called osmosis. And osmosis, what osmosis means is equalization. So it's equalizing the levels of concentration on both sides of that wall. Okay? So if you think about, so if I have ducks and chickens